In this video, I'm going to teach you how to calculate empirical formulas given the amount of grams that you have of an individual element in a compound. So what's important to recognize as background information is that a formula is not just a ratio of atoms, but is also a ratio of moles. So let's say you have 1 mole of carbon dioxide. If you have 1 mole of carbon dioxide, that means that you have 1 mole of carbon and 2 moles of oxygen. So sort of like when we just look at the molecule, the idea of a molecule having 1 molecule of carbon dioxide, that ratio of things tells you the ratio of atoms. So 1 atom of carbon for every 2 atoms of oxygen. So we can actually use this in terms of moles, and that's going to be important in terms of calculating the empirical formula. So the steps to calculating empirical formulas from grams is we start by converting the grams that we're given to moles, and then we find the lowest whole number ratio by dividing each number of moles by the smallest value. So you pick the smallest number of moles and you divide all the others, and that gives you the ratio. So let me do a couple of examples under the ELMO so you get the general idea. So the first one's pretty simple, and then the next one's a little bit more challenging. So I picked an ionic compound for the first one so that we can double check ourselves when we're finished to make sure that we know the answer, because remember that the empirical formula for an ionic compound is the same as its, I guess, molecular formula we would call it. So an ionic formula is an empirical formula. So what we do is we first convert each of these values into moles just by using the periodic table. So I'm going to take 3.66 grams of calcium, and I'm going to say, well, 1 mole of calcium is actually 40.08 grams of calcium. And then for chlorine, I have 6.389 grams of chlorine and 1 mole of chlorine. And if we look on the periodic table, it's 35.45. And in this case, even though chlorine is a Brinkelhoff, we're talking about chlorine being in a compound. So we're not going to double it. That's only when chlorine is by itself. So let's figure out the relative numbers of moles. So 3.611 divided by 40.08. So that gives me 0.09 moles of calcium. And then I'll do 6.389 divided by 35.45, and I get 0.18 moles of chlorine. Then what we do to figure out the ratio of the formula is we divide by the lowest number of moles. So I'm going to divide by 0.09 and divide by 0.09. And this is the step that students, as they're doing empirical formulas, they tend to forget. They actually try and like round these numbers and make those the ratio. But you make sure that you follow this last step, so you divide by the lowest number of moles. So that would be 1 to 2. So that gives you the ratio of things. So if we write the formula, it would be 1 calcium for 2 chlorines. And if we look on the periodic table, we can see that calcium's a +2 and chlorine's a -1. So if we crisscross down, this is actually the formula for calcium chloride. So we know that we did it right. All right, let's do one more. This one's a little bit more challenging, okay? So here we have aluminum, sulfur, and oxygen. So again, this is an ionic compound. It's actually an ionic compound with a polyatomic. So I'm going to get the empirical formula, and then we'll kind of try to reason out what the actual formula is. So let's do 2.16 grams of aluminum. 1 mole of aluminum on the periodic table says it's 26.98 grams. 3.85 grams of sulfur. 1 mole of sulfur is 32 grams of sulfur. And again, I'm just getting these values from the periodic table. I've just done this so many times that I know what they are. So 768 grams of oxygen, and 1 mole of oxygen is 16 grams of oxygen. And again, even though oxygen is a Brinkelhoff, we're talking about it in a compound, so we just leave it by itself. So we're going to take 2.16 divided by 26.98, and we get 0.08 moles of aluminum. I'm going to do 3.85 divided by 32, gives me 0.12 moles of sulfur. And then 7.68 divided by 16 gives me 0.48 moles of oxygen. Okay, now the last step is to divide by the lowest number of moles. So I'm going to divide each of these by 0.08. Here that gives me 1, gives me 1.5, and this will give me 6. All right. Now, if we're going to write a formula now, we can't use a subscript of 1.5. You can't have half of an atom or half of a mole when you're writing a formula. So if you ever come across this case, and you will always be like a perfect half, you're going to multiply each one of these numbers by 2, so you have all whole numbers, but then the same number, same ratio. So we'll multiply that one by 2, and so we're actually going to make this 2 to 3 to 12. Now let's write out that formula, and then we'll kind of think about how we actually would see it when we write out ionic compounds. So Al2, and then S3, and then O12. Okay, now that looks a little weird, right? But if you see sulfur and oxygen together and we're talking about an ionic compound, that should signal to you that we have some sort of sulfate. So actually, if I was going to write this how we write our formulas, how we learn to write our formulas, I do Al2, and then I do SO4 with a 3 on the outside. So you can see how that has the same ratio of things. We've got 12 oxygens, 3 sulfurs, and 2 aluminum. So this one's a little bit more challenging.